Okay, in number 25, we have the log base C of 27 over 21, and 27 and 21, they are both divisible by 3. So we could reduce that fraction and have the log base C of 27 divided by 3 is 9, and 21 divided by 3 is 7. So those are equivalent, and then we can see that this ratio 9/7, we could use the quotient property of logs to rewrite that as a difference of two logs. So the log base C of the numerator minus the log base C of the denominator. And we have expressions for log base C of 9, that's given as 1.057. And then the log base C of 7 is given to be approximately 0.936. And when we subtract those, 1.057 minus 0.936, we get 0.121. So the log base C of 27 over 21 is approximately 0.121. Okay, then in number 26, we want to approximate the log base C of 7 over 81. And 7 is in the numerator, so using that quotient property again, we would have the log base C of 7 minus, and then the 81 here is in the denominator, so log base C of 81. Now the log base C of 7 we have an expression for, but the log base C of 81 we don't. However, 9 squared is 81, so I could use the power property then. If this is log base C of 7 minus the log base C of 9 squared, I can use that power property to pull that exponent forward as the coefficient on the log expression. So then we would have the log base C of 7 minus 2 times the log base C of 9, and then we can substitute in our expressions that were given. So log base C of 7 is 0.936 minus 2 times the log base C of 9, which is 1.057. And then we can put that in the calculator. So 0.936 minus 2 times 1.057 is negative 1.178. Okay, so in number 27, the log base D of 33 over 8, we want to represent 33 over 8 using 11, 6, and or 4. And when you have fractions like this, if you recall, like in number 25, we had a 27 over 21. Those were both divisible by 3 and reduced to 9 over 7. So taking that concept but working the other way, if I were to multiply these both by 2, the numerator and denominator, that would give me a 66 in the numerator, and I could represent 66 as a 6 and an 11. So I'm going to go ahead and do that. I'm going to multiply the numerator by 2 and the denominator by 2, and I get a ratio in the argument of my log of 66 over 16. The 66 I can represent as 11 times 6, so that'd be log base D, and then in my numerator 11 times 6. The denominator of 16, that would be 4 squared, so I'll write that as 4 to the second power. Okay, then I can use my properties of logs. So in the quotient here, I have a subtraction using the quotient property, so that would become the log base D of the numerator, which is 11 times 6, minus the log base D of the denominator, which is 4 squared. Then I can use my product property on the product 11 times 6, so that would be a log base d of 11 plus log base d of 6. And then I can use the power property on this log base d of 4 squared by pulling that square, that exponent, out to the front as a coefficient to get minus 2 log base d of 4. And now I have all of my log expressions fully expanded into values that I can substitute that were given. So the log base d of 11 is approximately 2.183. The log base d of 6 is approximately 1.631 minus 2 times, and then the log base d of 4 is approximately 1.262. So we can put those values into the calculator, and we'll have 2.183 plus 1.631 minus 2 times the quantity 1.262, and that's approximately 1.29.